Now let's go to the exercise that we will do in the real hardware. So as earlier we tried the 7-segment display with the simulator. Now we are taking the real 7-segment display and connect that to our processor module. Here's the picture what we should do next. So here's our nano module, processor module, and here's a USB connector, micro USB that will be connected to PC. So the code will be loaded through this USB cable from PC. Here's the 7-segment display. There are the series resistors are already installed for the small board here, and here are the wires from the 7-segment display to our processor module, and this white board is the test circuit board that we are using to our trials to connect those wires to make our circuits. Here's the schematic diagram that how we should do the connections in our exercise. Here is the 7-segment display, and here are the series resistors, and they are connected to our processor module. And the circuit diagram is basically the same as we use with the simulator, but now there is this common wire goes to plus 5 volt here. Here's the 7-segment board pin wiring. Here are the segments and the common voltage for all segments. So here you can see how to do the real hardware wiring to the 7-segment display. And here are shown the pin wiring for the nano module. So we are using these D port signals here, and notice that this, if you start from here, this is D1 and D0, but in here the next numbers go in normal order from D2 to go on until D12. And here in this table is shown that how to connect these segments to these port D pins. The wiring is like in the same way as in the simulator, so you should be quite familiar for these connections already. Notice one thing before start to load the program to nano module. In this nano module there is that USB circuit or USB chip which is connected to PC. That chip is using these D0 and D1 lines. So it means that when you are loading the program to nano module, you should remove your own wires from these lines from D1 D0 and load the program, and when the program is loaded, then you reconnect back your own wires to that D1 and D0 lines. Those are showing here. So when you load the program, don't put any wires to here, and after that when the program is loaded to nano module, then you can connect back your wires. It's because if you keep these connected to your own circuit, it might be possible that your connection prevent this USB chip to be working. So it means that then the program cannot be loaded to nano module. So the exercise 5 is that you can use the earlier subprograms that you did make last time, and now you can try that, test that program with the real hardware. So the idea is that try to get printing the numbers from 0 to F, the 7-segment display, and keep half-second delay between the numbers. So with this functionality you can test that the real hardware is also working. And your program is supposed to be working because you have tested that already in the simulator. And one other note is also that in here this is the common anode 7-segment display, which means that the common wire for all segments supposed to be connected to plus 5 volts. And then it means that that logical 0 here will illuminate the LED, and if the status in these bits are logical 1, it means that the LED is black. So it's the opposite functionality compared for that simulator exercise. When in simulator, when you did have logical 1 and that was illuminating the LED, now if you put logical 0, that will be due to illumination for the LED. So you have to invert your bit statuses compared to your earlier program.